Hi, this is Mrs. Davis. I am teaching Calculus Lesson 8.1, Average Value of a Function. And so let's just get started. Okay, so there's three things to remember to kind of make this make sense. So we'll go through, and it's good review anyway. Let's talk about, first, we're calling the intermediate value theorem. So the intermediate value theorem said that if f is continuous on an interval AB, closed interval AB, and L is any number between f of A and f of B, right, then there must be a value, an x value, right, C, where A is less than C is less than B, such that, let's write such that, right? F of C equals L. All right, so that was the intermediate value theorem. Then we have the average rate of change, and you remember that that is the f of b minus f of a over b minus a. Okay, and then the third thing is to remember that the mean value theorem, you had to add that it was, continuous on the closed interval and differentiable on the open interval, and f prime of c is f of b minus f of a over b minus a, and then sometimes they ask you to find c. All right, so let's see how all this relates to what we're talking about, and it's the average value of a function. And the first thing we want to reiterate is it's not the same thing as the average rate of change. So there's this whole circuit about average stuff, and there's more than one. It's not, every time you hear the word average, it's not average rate of change. So there's this other thing called the average value. Let me talk about what the average value is from a picture standpoint. So here we have a function right here. Okay, I'm looking at the picture. And if we wanted to make this curve into a rectangle, okay, so we would push that down and push that up so that we would have a perfect rectangle that was the same area as this curve area under the curve. All right, and so that's what this box is right here. And this right here, this y value is the average value. Okay, so it's sort of saying, hey, I know where it would make sense. Let's see, if you were to, let me see, I think I had one example in my head. If you were to throw a kickball, let's talk about it down here actually. If I were to kick a ball up here and here, okay, then I wanted to know the average height. So this is the height. Let's say that's the height. And so the average height might be somewhere in here, okay, if I were to press everything down into a rectangle. Actually, probably it's going to be more up there like that, but anyway. So you would kind of know, well, what was the average height? Here was the tallest height up here, and here's the lowest, but what's the average? And it doesn't mean the average, it means the average value, okay? So that doesn't mean, that you're just taking the top and dividing by 2. All right, I'm going to erase that because this problem is for something else. Okay, so now that we kind of can visualize what we're talking about on the average value, let's see what it is. So the average value of a function on an interval, it has to be closed interval, then the average of f on that interval is 1 over b minus a. So you're looking at this interval up here, from a to b of the function. Now, what you need to know, and which is probably the most important thing I'm going to tell you today, so I'm going to use like purple, is that that the average value of something, so I'll write it here, the average value of something has the same units as something. Okay, so if you ask for the average height, then it would be in feet. Okay, so if I ask for the average velocity, okay, than it would be in velocity. Okay, now the first few examples that we do are not word problems, so that won't become as clear to you until we do a few word problem ones. But that's what you need to remember. Like if you take the average rate of change, you're going to get a rate. If you take the average of something that doesn't start a rate, you're going to get, whatever it started with back. So if you take the average rate of change of velocity, it's going to be feet per second squared because it's feet per second. And then if I take the average rate of change of that, it's feet per second squared. But if I take the average value of velocity, I just get feet per second back. I hope that is clear, or it becomes clear. All right, where does this come to? Well, if you look at this function right here, which we know is the average rate of change, S prime of t is S of b minus f of a over b minus a. Okay, and so if you rework this, and we were using some of the things from up there, and you say, okay, well, S of b minus S of a is the same thing as the integral of a to b of S prime of t dt. So I'm just going to rewrite like that over b minus a. And then you can just pull the b minus a out in front. It's just bottom, right? And which is going to be a number. And then it's the integral of a to b of S prime of t dt. So that's where this comes from. Okay, it's just a rework of that equation. All right, so let's do a couple of examples. Find the average value, okay, of f of x is 6 minus x squared on negative 1 to 3. So you're going to start off, and it's good to write it. Of course, you need a left-hand side, but it also, if you write it, it makes you think of what you're doing, because you're going to write that value, the word value out, is equal to 1 over 3 minus negative 1. Remember, this is going to be worth a point. It is. Negative 1 to 3 of f prime of x dx. Now, you don't have to write the 6 minus x squared, etc. Okay, actually, this should be just f of x, because we're just taking the average value. So sorry. All right, so that would be 1 over 4, the integral of negative 1 to 3 of 6 minus x squared dx. And so now you just take the antiderivative. It's 1 over 4, and then it would be times 6x minus 1/3 x cubed from negative 1 to 3. So this is not a very nice one, but let's get what we have. We have 1/4, and then we're going to have two pieces. So we're going to have 18 minus, this would be 27 over 3, so 18 minus 9 for the 3, minus, and then it would be negative 6 minus negative 1/3. So you end up with 1/4 times 9 plus 6 minus 1/3. And if you do the math, that comes out to be negative 44 over 12, which comes to 11/3. Okay, so that's the average value of 6 minus x squared on the interval negative 1 to 3. So we're looking at, if we're looking at graphing this box or whatever, 11/3 would be, 3 2/3? So about here is going to be where your average value is. Okay? So then when does the function assume this value? So we're looking at this point right here and this point right here. It's like, where does the function assume that value? Which can be used for different things. So we also have to watch out that they want it on negative 1 to 3. So I can already tell that this one is not going to be included. It's just going to be this point right here, this x value. But so let's figure it out. And it's very easy to figure it out. You just take 11/3 and put it back into the original equation, because this is the function, right? So if I have the y value, I can find the x value. So 11/3 is equal to 6 minus x squared. So x squared is 18 a minus 11 over 3, which is 7/3. So x is plus or minus the square root of 7/3. And so this would just be, so on the interval, okay, this is x equals square root of 7/3. Oops, positive square root of 7/3, right? So there you go. So that's very frequently they ask these two things together. All right, and so there you have it. All right, let's look at one more example on this video, and then we'll change the video to the next page. Find the average value of the function over the given interval and all values of x in the interval for which it equals its average value. So same thing we just did. Different way, kind of say it, but same thing. All right, so, all right, let's do this one. So we would say the average value equals 1 over 4 minus 1. So average value, just remember, it's got that piece. And then it's 1 to 4 of 3x squared minus 2x dx. Or you could have said 1 to 4, 1 over 4 minus 1 of f of x dx, either one. They'll give you credit for that point for either one. All right, so this one doesn't seem so bad. This would be 1, oops, I lost my pen, 1/3. And then it would be x cubed minus x squared from 1 to 4. So that's 1/3 of 64 minus 16. And then that would be 1 minus 1, so 0. So this is 1/3 of 48, which is 16. So your average value is 16. Of f of x on 1 to 4 equals 16. All right, then it says, for what all values of x in the interval, when does it equal its average value? So then we have to put 16 back into our original equation. So 16 equals 3x squared minus 2x. So 3x squared minus 2x minus 16 equals 0. That'll be 3x minus 8 and x plus 2. So x is positive 8/3 and negative 2. And negative 2 is not in the interval, so we just have x equals 8/3. Okay, so that was the first video for lesson 8.1, average value of function.